You can run Qwen 3.8 27B without an RTX 5090. In fact, you can run it without a dedicated GPU at all. A powerful graphics card can make this model very fast. A Mac can keep the model inside its shared memory. And even a normal computer with enough RAM can run it through the CPU. It will be slow, but it will work completely locally. There is even a last resort method that uses RAM and a fast SSD when the model does not fully fit in memory. I would not recommend it for daily use, but it shows how far local AI has come. The real question is not simply, can my computer run Qwen 3.8 27B? It is, which version should you download, how much context can you use, and will the final speed be good enough for what you want to do? So in this video, we'll cover the best setup for NVIDIA GPUs, Apple Silicon Macs, lower-end graphics cards, CPU-only computers, and even systems that need help from an SSD. By the end, you'll know exactly which version fits your device and the easiest way to start using it. But first, we need to make one confusing part very simple. Qwen 3.8 27B has 27 billion parameters. The full model needs roughly 56 gigabytes just for its weights. It needs even more memory once you add context and the software running it. That full version is not what most people will download. Instead, local users will choose a quantized version. Quantization stores the model with fewer bits, making the file much smaller. Quality can drop, but a good 4-bit version usually gives the best balance. The rule is simple. Download the highest quality version that fits while leaving free memory for context. A model that fills every last gigabyte may load, but even a small context can push it out of memory. For most people, Q4 is the best starting point. Q5 or Q6 is better if you have more memory. Q3 can help on smaller systems. Q2 is the emergency option when nothing else fits, but the quality loss is more noticeable. If you have a 24 or 32 gigabyte GPU, start with Q4. The full quantized model can stay on the GPU, leaving room for a useful context window. This is the best experience for most desktop users. With 16 gigabytes of VRAM, Q4 can be very tight. A smaller Q4 or Q3 build is safer, especially if you keep the context at 8K or 16K. With 12 gigabytes, Q3 or Q2 may fit with limited context. With 8 gigabytes, llama.cpp can place some layers on the GPU and run the rest through the CPU and RAM. It will be slower, but the GPU still helps. On an Apple Silicon Mac, the CPU and GPU use the same memory pool. A 24 gigabyte Mac can run a 4-bit version, but it will be tight. A 32 or 36 gigabyte Mac is much more comfortable. With 48 or 64 gigabytes, you can use a better quant and more context. And if you have no GPU, the model can still run through the CPU. You will want at least 32 gigabytes of RAM for a practical Q3 or Q4 setup. 64 gigabytes gives you much more room. That tells us what fits. The next step is choosing how to run it. For most beginners, I would start with LM Studio. It works on Windows, macOS, and Linux. It gives you a visual interface, finds GGUF models, and lets you control GPU offload without writing a long command. Install LM Studio, search for Qwen 3.8 27B, and choose a trusted community, GGUF. Start with Q4 if your device has enough memory. If it does not fit, move down to Q3. Before loading the model, set the context to 8K or 16K. Do not begin with the official 262K maximum. That number may look impressive, but context uses memory. A smaller setting is faster and far less likely to crash. Then load the model and check the offload setting. If you have a strong GPU, move all possible layers to the GPU. If you have an 8 or 12 gigabyte card, let LM Studio place only some layers there. The remaining layers will stay in RAM. You can now chat with the model, use image input if the selected build supports it, or start LM Studio's local server and connect another application. This is the easiest path. For more control, use llama.cpp. Llama.cpp can run GGUF models on NVIDIA, AMD, Apple Silicon, and CPU-only systems. More importantly, it lets you decide how much of the model goes to the GPU. A simple server command will look something like this. The Hugging Face option downloads the model. The NGL999 flag tries to place all layers on the GPU. Flash attention is enabled. The context is set to 16K, and the local server opens on port 8080. If your GPU is too small, lower the number of GPU layers instead of using 999. The exact number depends on your VRAM. Start low, watch memory use, and increase it until you find the best balance. Once the server is running, open localhost 8080 in your browser. You can also connect a coding tool to localhost 8080/v1 as an OpenAI-compatible endpoint. The exact repository name and MTP options may change as the first Qwen 3.8 builds mature, so check the current model page before copying the command. If the whole model fits in VRAM, generation can feel like a normal cloud chatbot. Qwen 3.5 and 3.6 use the same 27B hardware class, so their results give us a useful starting point. RTX 3090 and 4090 users have reported roughly 30 to 40 tokens per second with 4-bit builds and sensible context settings. New Qwen 3.8 reports show much higher speed on an RTX 5090 when multi-token prediction is enabled. But do not copy that number to every GPU. Speed changes with the quant, context, runtime, MTP support, and prompt length. On a 16GB card, leave enough VRAM for context. On 12 or 8GB cards, partial offload is the realistic option. Each layer moved to RAM saves VRAM but reduces speed. Once much of the model runs there, RAM bandwidth becomes the limit. Still, this can be useful. You do not need 30 tokens per second for a coding agent that works in the background, a private document task, or a job that runs overnight. What hardware are you planning to use for Qwen 3.8 27B? Leave your GPU, CPU, and RAM in the comments. That will also help other viewers find results for similar systems. Macs are different because the CPU and GPU share unified memory. The model, context, and applications use the same pool. This makes large models easier to fit, though not always faster than a powerful NVIDIA card. Qwen 3.6 users reported around 16 to 18 output tokens per second on an M1 Max with 64GB. In another test, an M5 Max with 108GB produced around 17 to 18 tokens per second at 8-bit, and about 32 with llama.cpp plus MTP. Qwen 3.8 has the same model size and a closely related architecture, so these numbers are a useful guide, not a guarantee. For a 24GB Mac, use Q4 and keep the context small. For 32 or 36GB, Q4 should be more comfortable. At 48 or 64GB, Q5, Q6, or even Q8 becomes possible depending on context and the app. MLX is built for Apple Silicon and can be a good option, but llama.cpp has also performed very well, especially when MTP works correctly. I would test both instead of assuming one is always faster. CPU-only inference is slow, but it is real. One early Qwen 3.8 report showed around 4 tokens per second on an older laptop using a 4-bit model. A high-end EPYC server running Qwen 3.6 Q8 fully on the CPU reached about 10.7 tokens per second. The difference is not only the CPU, RAM speed and memory channels matter a lot. A server with many memory channels can feed the model much faster than a normal dual-channel desktop. For a typical PC with 32 or 64GB of RAM, expect a few tokens per second. Large documents and projects will also take time to process. But slow does not mean useless. CPU only can work for offline document analysis, private files, batch jobs, overnight coding tasks, and systems where buying a large GPU makes no sense. Use llama.cpp, choose Q3 or Q4, keep context low, and make sure the model file itself fits comfortably in RAM. But what if it does not? Llama.cpp normally uses memory mapping. Instead of copying the entire GGUF file into RAM at once, the operating system can load pages from the model file when they are needed. This means a model can sometimes start even when the GGUF is larger than your free RAM. A fast NVMe SSD holds the file, RAM caches what it can, and llama.cpp keeps reading missing parts from storage. Unsloth also notes that llama.cpp can use SSD or even HDD offloading. But Qwen 3.8 27B is dense. Every token passes through the entire model. If the weights are not cached in RAM, the computer may read them from storage again and again. RAM bandwidth is measured in tens or hundreds of gigabytes per second. Even a fast NVMe SSD is much slower and has far higher latency. Token generation can collapse. the first prompt may take a very long time, and the rest of your computer may become less responsive. Do not use the mock option for this method, because that tries to lock the whole model into RAM. Keep memory mapping enabled and store the GGUF on the fastest NVMe drive available. Also close other applications, and use a very small context. I would not use this for an interactive coding assistant. It is mainly useful for testing or running one private job overnight. And if your computer begins using normal swap space heavily, stop. Reading static model pages through memory mapping is one thing. Constantly moving normal memory in and out of a page file can cause extreme slowdown and extra SSD writes. So yes, SSD plus RAM can make the impossible possible. Just do not confuse it runs with it runs well. Once Llama server or LM Studio server is running, Qwen becomes more than a chatbot. Point, OpenCode, Pi, or another OpenAI-compatible coding tool at your local address. For llama.cpp, that will usually be localhost 8080/b1. The API key can be a local dummy value if the client requires one. Now the agent can read your project, use the terminal, change files, and test its work while the model stays on your machine. A CPU may handle one long task, while a 24GB GPU will feel far more interactive. Almost any modern computer with enough memory can technically run Qwen 3.8 27B. The real difference is speed. A 24GB GPU gives the best balance. A 32GB Apple Silicon Mac is usable. A 12 or 16GB GPU can run a smaller quant. An 8GB card can help the CPU through partial offload, and a CPU-only computer can still run the model if you are willing to wait. If the model does not fit in RAM, a fast SSD and memory mapping may still start it, but that is a test or overnight method, not the setup I would choose for daily work. So do not ask only, can my computer run it? Ask, which version gives me the best balance of speed, quality, and context? If this video helped you, leave a like and subscribe. In the next test, I'll connect Qwen 3.8 27B to a real local coding agent and compare how much quality different quantizations actually lose.